Hey, welcome to my YouTube channel, Looking Over Strange Terrain. My name is Javier Mackey, and today I'm going to talk about plotting grids, determining your azimuth. Then I'm going to touch bases on, because I can't remember if I did major terrain features and minor terrain features, as well as the colors of the map. So I'm just going to touch on that just in case I didn't before. And then we were going to how the map is broken down to plot a grid. And I had a lot of fun with this one. There's a lot of, actually, it was more work than I thought it was going to be. But at the end of the day, I was able to relearn a bunch of things that I've forgotten a little bit about. Life has been good for me. Again, work has been work, and being able to spend some time with the family, that's a good thing. But let's go ahead and roll right into map reading and plotting coordinates and azimuths and crap. All right, so what you see here are the longitude and the numbers that represent the longitudinal lines and the latitudinal lines. The longitudinal lines are the ones in the yellow box. Those denote your north-south lines. So the lines that go up and down are the longitudinal lines. The lines in the pink or the rose-colored boxes are the latitudinal lines, and those represent east-west. All right, these are the latitude lines. This is just to show you where the zeros meet at on the latitude lines. The numbers represent, the numbers on the side here represent the latitudinal lines. And the example, I omitted the longitude lines. So when you see it as a 4-digit grid, in this instance, you will have whatever the longitudinal coordinates are, followed by the 00, which is the latitudinal coordinate for that line. The same with the 6-digit. So just to show you what that looks like, I put X's for the longitudinal lines, and for the latitudinal lines, you see the 002. If you go below that, if you go below that, you see the X's again for an 8-digit grid with the 0025. And that basically tells you exactly what I'm talking about. All right, it's talking about the latitude lines that you're going to use to pinpoint where your point is on a map. All right. So the numbers up the top here, they represent the latitudinal lines, just like what you saw on the longitude, that are on the side. Just like I showed you in those examples, you're in this case, the box that I'm using is in the Echo Tango quadrant, so it would read 16 Sierra Echo Tango 97 for 4-digit XX, 6-digit, and I'm only doing the longitudinal lines because I wanted you to see the difference. You have 16 Sierra Echo Tango 972, and then you have 16 Sierra Echo Tango 9725 XXX for the 8-digit. So the first numbers, and I put the X's here so that the first numbers you read, I want you to understand those numbers are going to reference your longitudinal portion of the grid. The second set is going to represent your latitudinal lines. All right, we're talking about 100,000 meter square identification. For this particular map, we have 4 maps in one. Up here, the identification for the upper left-hand quadrant here is Echo Tango. To the right of the upper quadrant, we have Fox Tango. To the lower portion here of the quadrant, on the left-hand side here, we have Echo Sierra. And then over here, we're going to have Fox Sierra. So I hope you can see it here. This is, at this point right here, is where all 4 maps meet. So if I was to plot a grid for that intersection, it would 8-digit grid would read, gee, I don't know if I wanted to put just that spot, which one you would use. But either way, it would be 0, 0. I guess it wouldn't matter at this point. It would be 0, 0, 0, 0, 0, 0, 0, 0. That point right there where 4 maps meet. All right, so for instance, if I was plotting a grid in this quadrant here, this would be 16 Sierra, Foxtrot Sierra. If that's how it would start it off. In this particular square here, it would be 16 Sierra, Foxtrot Tango. Here it would be 16 Sierra, Echo Tango, and then this would be 16 Sierra, Echo Sierra. So anytime I get a grid, I will automatically know where in the 4 quadrants it will lead. Now this is a particular special map. You will not find that on all maps. Some maps will have at most 2, but this particular Fort Knox map will only have, it particularly has 4. I know the first thing I'm gonna write down is 16 Sierra, Echo Sierra, and then I know it's been my longitudinal line is 8-2. My latitudinal line is 8-8. So I know the big grid square I'm looking for is right here, is 8-2-8-8. All right, and this is how I'm gonna write it down. So I put 16 Sierra, Echo Sierra, 8-2-8-8. Next, I want to figure out, now that I've identified the big square, now I want to go to find out exactly where it is in that square that that building is. So this is where I'll take my protractor, and because this is a 1/50,000 square, what I'm going to do here is start from, remember I said read from right to left. I'm going to make sure that everything is lined up. My left and right square. Then I'm going to slide it all the way across to here. So where the left-hand longitudinal line, where this line right here lines up with my protractor, it reads 6-1. So next to the 8-2, I'm gonna write the 6-1. And then for my latitudinal line here, it looks like right at 1. So that's 1-0. All right, so this is what my grid square will look like. Or this is what my written grid would look like. 16 Sierra, Echo Sierra, 8-2-6-1, 8-8-1-0. And this is how you would read it off to someone else. So if you're passing along this grid to someone else, this is exactly how you would do it, because this gives them all the information needed to find a grid on the map. Normally when they pass it along, they'd be like, all right, prepare to copy. And that tells the person that you're giving the information to that be ready to write it down. And they'll say, hey, 16 Sierra, Echo Sierra, 8261, 8810. Boom. All right. So from there, I can pretty much decide anywhere on this map I want to infill. Normally, you want to put a terrain feature between you and your objective and for observation, but I don't find that to be realistic once you're on the ground, because you know the terrain once you get on the ground may look very different on the ground than it does on the map. So what we're going to have here, I'm going to go ahead, I'm going to infill right up here. All right, and you notice I'm not writing on my map. I'm not writing because this is paper, and I just don't like writing. It's just a habit. I'm also not, you see, I'm not using my finger to point objects out on the map. I'm using an object that has more of a point. And so whenever you're using a map and you're talking somebody on to a map, you're going to always pick up like a needle. The best is pine needles or a pencil to do all your pointy talkies. All right. So I'm going to infill just beyond, about 100 meters beyond this depression. All right, so I want to get 100 meters beyond that depression. So what I'll do is I'll get my protractor here, and I'll use this as a guide. So from the 9 to the 1000 here, that's about 100 meters. So what I'm gonna do is just plot a point up on the map there. So let's start it off. Let's do it right. So I'm right down, my infill point is 16 Sierra, Echo Sierra, 8289. Okay, so I know it's 8289, and then I'm gonna slide it over. Let's see, and then whenever you do a terrain feature, what you want to do is you want to line it up so that you're cutting it in half, and wherever you find center is, that's where you want to plot. But from here, so I want to go 100 meters beyond that, so my infill point's going to be, so 8214. That's just below that 5 line, and then just above it, I want to do 89. Just call it 8990. All right, make it easy, because there's no definable terrain feature beyond that depression right here. Okay, that's what I'm talking about. All right, adjust the light here. All right, so now that, and this, just for this example, I'm gonna break my rule and go ahead and, so that's how we plot a grid. All right, so we're gonna say that's my grid and that's plotted. All right, and then we're gonna go to this building right here, which is my objective. All right, so now once I'm on the ground, I need to know what direction to walk in, right? So I need to know what direction to walk in from that point to get to this point. So what I'm gonna do is I'm gonna go ahead and I'm gonna put this little hole here on that dot that I drew. And give me a second, I'm gonna have to find a straight edge. Or I can just draw a line. So for this demonstration, I will draw a line. And I'm going to use a lead pencil for that. All right. So that way I can just erase it and preserve my map, because these maps are hard to get. All right, so if you're not in the military. So all you're going to do is just draw a line. What you want to do is make sure that line is long enough for you to... Now, I use a 0.7, I believe that's a 0.7 or is a 0.5, 0.5 pencil lead, mechanical pencil. In fact, this is the same pencil I used for 20 years of my career for land navigation. So this pencil is old, and you can still find them. It doesn't matter. Anyway, I like 0.5. This pencil went through selection with me, and it went through every deployment I ever been on, and TDY. So from this, I want to make the line long enough so that I can actually get an accurate azimuth. So this is going to be a grid azimuth. All right. So what's really important here is to make sure this line right here on your protractor, this line right here on your protractor, and this line right here on your protractor are perpendicular and vertical to line. So you want this to be as straight as the protractor line here. You want it as straight as the printed line. All right, and you're just going to follow that line down here to the inner circle, and the azimuth is 155. All right, so I'm going to write that down. So my azimuth is 155 degrees. This is grid. This is a grid azimuth. All right. So the declination for this is I need to add a half a degree. So my magnetic, I'm gonna just round it up. I'm gonna round that number up to 156 degrees magnetic. All right. So when I get off the bird, truck, or whatever, I know I'm gonna look at my compass, and I'm going to, on my compass is going to read 156 degrees. I know I'm moving south. All right. So once that's been accomplished, the next thing I need to do is figure out how far am I going. All right. So there's a couple ways you can do this. I'm going to show you what I use for the protractor. So I must go ahead and start at my end point. All right. And because I know each of these lines represents, one, that's 100 meters, two, that's another 100 meters, so 300, 400 meters, all the way up to 1,000 to 1 kilometer. So let's see. Each of these squares represent a square kilometer. I'll look at it. All right, that's a kilometer. I know at least from this point here to this point is 1,000 meters. So I'm going to use that as my measurement. So I'm going down here to where my objective is, my OBJ. I'm going to go ahead and mark an X there, and I'm going to put a tick mark. That's 1 kilometer. And then now this is about 19. So 1900 meters. Okay. So this is where I'm going to use my pace count. Starting from here to here, it's going to be 1900 meters. But I don't want to sit there and think about it in terms of 1900 meters. So what I'll do is I'm going to give you the first little iteration on route planning. Sometimes it's not conducive to walk in a straight line. I might want to avoid these buildings here, especially if I'm doing a reconnaissance. So my best bet is to use the terrain and cross over at a distance away from the houses, right? But I really don't care at this point, and I just want it for teaching purposes to go over getting from point A to point B in a straight line. So starting here, I'm going to measure from this point to this point. Our first stop is from start point to depression. So I'm going to put SP to depression. I'm just going to do DP. So let's go ahead and measure that out using the protractor. So using a protractor, using a 150 meter scale, the 1/50,000 scale, and that's roughly 150 meters. So my first checkpoint is going to be 150 meters. All right. Now I'm looking for a second depression next to a pond right here. All right, so that distance, I'm gonna measure that out. Starting from the center of that depression, and that's roughly about 500 meters. All right, so from depression to depression is 500 meters. All right, so I wrote that down. So that's my second checkpoint. All right, so the next checkpoint, so these features don't generally move, but because it's dirt and it's in, so you got to do some terrain analysis. So because this could be a rock depression, so that can fairly well be there all the time. But say for instance, like a dirt depression, that can get filled in really easily. So and the ponds usually could be dried up. So you can't totally be totally reliant upon seeing these actual key terrain, pieces of terrain existing on the map, especially since this is a 1971 map. So there's a good chance that this got filled in, or the erosion has broken it away. But yeah, those depressions, I can't count on that. I can count on this road being there, right? So my next point is going to be from this depression here to this road here. All right, and let's measure that out. So, and as you see, I'm always going from where my next objective is to where my last objective was. So that's about 400 meters. All right, so from that point, so let's go depression to road. And that's 400 meters. All right, so that's my third checkpoint. So now I got 3. I'm just going to go ahead and go 1, 2, 3. All right, so from there, from that house, we're going to use that road to the next house down here, and we're going to go ahead and measure that, and that's where we're going to end up. So, and there's no other identifiable pieces of terrain that I can use as a checkpoint between there, and that's fine. I'm happy with that, and that's about 950 meters. All right, so from road to OBJ is 950 meters. All right, so this is what so what I'll go ahead and do is, because I'm going to be staying on the same azimuth all the way through, I'll do that. So with this information here, I'll go ahead and put this as a start point, and this is be my OBJ. I'll say this is all the information I need without even really looking at a map. This is all I would need to get from one point to another. All right, the way back azimuths work is if the azimuth you're on is greater than 180, you're going to subtract. If the azimuth that you're on is less than 180, you're going to add. Basically, you want to, if you go over 360 degrees, then doing either adding or if you're and you're over 360 degrees, then you need to subtract. Just basically do it that way. But so because we went on a 156 degree azimuth, that's less than 180. To backtrack, my azimuth is going to be 336 because I'm adding 180 degrees to the 156 degrees to give me a back azimuth so I can go back to my point. And so what I'll do is just backtrack. So my backtrack is going to be at 336 degrees magnetic back to my start point. And then I can just use that. So from the road to the depression is going to be 900 meters. The ejective to the road is going to be 950 meters. From the road to the depression is going to be 400 meters. From the depression to the next depression is going to be 500 meters. And then from the depression to my start point is going to be 150 meters. Now these numbers might not add up. I had to guesstimate just based on the scale that I used, but this would give me around the ballpark of 1900 kilometer or 1900 meters or 1.9 kilometers, however you want to say it. All right. So I went over back azimuth. All right, so a hill is an area of high ground. So so this is the high ground. Remember, I told you that as you go up the high ground, the circles get smaller. So for a hilltop, the ground slopes down in all directions. So here we have a hill that slopes down in all directions. Where's a better example? Here we go, right up here. So we have a hilltop here. It's not very steep, but it slopes down in all directions in concentric circles, the smallest being the hilltop itself. Then we have a saddle. So it's a pair of adjacent hilltops. The saddle is actually the low portion between the two higher portions. So here we have B-Knob Hill, and we have a saddle right there. All right. Over here, we have a ridge. So you have so this is generally a ridge right here. This is a ridge right here. All right. And a ridge normally is like attached to a series of other major terrain features, but it's most notable as the back or the stem line of a mountain. You know, so you see the skyline of a mountain and you're looking at its top. That's the ridge. All right. It usually have like some type of knife cutting. Looks like a knife cutting edge, like that could be used as the sharpened portion of a knife. All right. And what you'll have sloping, it will slope in 3 directions. All right. So that's a ridge. Next is a valley. So this map doesn't really do a good job depicting a valley, but let's say for poops and giggles, we move it over here to this is a pretty good example. You have high ground over here to the left, and then to the right you have high ground, and then to the center you have low lying ground. This major terrain feature is a valley. All right. And then let's talk about a minor. So depression is a major. So a depression is a low point in ground or a sinkhole. It could be described as an area of low ground surrounded by higher ground in all directions, or simply a hole in the ground. Usually, only depressions are equal to or greater than the contour interval that will be shown on maps. Depressions are represented by close contour lines that have thick marks pointing toward the low ground. So in this instance here, you look, let me get you closer. You can see the tick marks here are pointing inward. So this tells me it's a depression. And if you look down here, this is even better. You have a depression, and then you have a depression inside a depression. All right. So the minor terrain features are draws, spurs, and cliffs. All right. So let's see if I can find you so let's go a spur. So a spur, unlike a draw points away, is a short continuous sloping line of higher ground, normally jutting. So here, like in this point, this is a spur because it's higher ground jutting out of from the side of a ridge. A spur is often formed by two high parallel streams cutting through draws down the side of a ridge. So this kind of fits right here. We got a spur, this higher ground, and water would normally flow in these areas. Those are spurs. All right. Although this map doesn't depict it, I'm sure if water was to run down this map, it would definitely run down these pieces of terrain here. A cliff, on the other hand, is going to look a little bit different than a depression. All right. So the closer, it's going to look like eyelashes. So let me look around. Give me a second. I'm going to pause it. All right. So I went over plotting, a grid, azimuths, back azimuths, a little bit of planning. I don't want to go getting too much into the weeds of that. I would do that in another episode. That's a lot to talk about, and it's kind of fun. But you can, so grids, plotting, azimuths, back azimuths, which is pretty cool. And then I also went over the major terrain features and minor terrain features and colors you'll find on the maps. One thing I didn't cover, black will denote buildings on the ground. Red and white stripes will tell you the major roads. If you see two lines running parallel with one another, that's an improved road. The dashed lines are unimproved roads. You got power lines. You got a bunch of stuff that you'll find on a map. I just didn't want to cover all of it. But they're pretty fun to mess around with. If you're doing D&D, there's nothing wrong with, I would say use a military map or an atlas for your D&D campaigns, and then you can use that as your world, kind of make it kind of realistic to where you're at. But anyway, you can nerd out on that all you want. Another idea. So that's it for right now. Life has been good. I've been busy with work. You heard that chime. That was work as I was doing all this talking. But I hope you got a lot out of it. I'm trying to keep these short, just about 20 minutes at most. Like, subscribe, tell a friend. You can follow me on Twitter. My handle is looking over, or you can just type in looking over strange terrain. I should pop up with that. For a lot of you military guys and gals, it's the community I kind of roll with, and Twitter is pretty cool. Mil Twitter, the goons, they call themselves. They're really good people. The people who have subscribed to the channel have been really gracious so far. I need to get better content out there. I think this is fine for right now, but oh well. That's all I have. Stay tuned. Stay alive. Deo presso libere.